Good morning, students. Welcome to the second lecture on nuclear power generation, which is part of our course on power generation and economics. Learning objectives. At the end of this video lecture, students will be able to apply the site selection criteria for a nuclear power plant, discuss the various concepts like nuclear reaction, nuclear fission, and nuclear scattering, illustrate the working of a nuclear power plant with the help of plant layout. Site selection criteria for a nuclear power plant. Here are some of the important factors for selecting a site for a nuclear power plant. The first and most important factor is the availability of water for cooling purpose. The water is freely available on riverbeds and seashores, and hence those sites are ideally suited for a nuclear power plant. Also, the distance from densely populated areas. If the distance is high, then it is a preferable site because the nuclear power plant can have adverse effects on human health and environment. Also, disposal of radioactive waste is also a concern since radioactive material exists in air and wastewater coming out of the nuclear power plant. Distance from load center. If the distance from the load is quite high, then the power transmission losses are quite high. Availability of transportation facility for nuclear fuel and for the transportation of maintenance and operating personnel. Accessibility is also a important concern as it connects the nuclear power plant from the external world through rail and road. So the main two factors which we have to keep in mind while selecting a site for a nuclear power plant are availability of water for cooling and the fact that the nuclear power plant site should be remotely located. So these are the two main factors for selecting the site for a nuclear power plant. Nuclear reaction is a reaction in which two or more nucleons or nuclei interact with each other to form nucleus or nuclei of different physical properties. This could result in release of energy or alpha beta particles and gamma rays. Also, some nuclear reactions only lead to direction change of a nuclei with no release of energy or no notable change in physical properties. Such nuclear reactions are called nuclear scattering. Also, some nuclei which participate in nuclear reaction might be lost in the system or might go extinct. Such reactions are called absorption. Nuclear fission is a nuclear reaction in which a heavy nucleus of a radioactive metal undergoes splitting when a neutron is bombarded to such a heavy nucleus. The nucleus is split into lighter nuclei which show a measurable change in mass. This change in mass is released as energy, which is in the form of heat. This heat can be utilized by thermal power plants, as we have studied in Module 2. Now, what is meant by chain reaction and what is meant by a nuclear fuel? Chain reaction is a process in which neutrons emitted from a nuclear fission further undergo fission. They bombard other nuclei and result in more and more fission reaction. Such chain reactions are caused by only 1.1 neutrons on an average. Although 3 neutrons are emitted in every chain in every fission reaction, but only 1.1 neutrons exhibit chain reaction. This chain reaction can be destructive and can be utilized in an atom bomb, but it can be controlled for peaceful purposes like power generation. Control rods can be inserted or can be removed from a nuclear reactor, resulting in decrease or increase of chain reaction. This chain reaction is the main component in a nuclear reactor. The nuclear fuel is a radioactive metal which is refined and obtained from natural sources, and this whole process is called a nuclear fuel cycle. The nuclear fuel cycle may result in uranium 235, which is a natural radioactive metal source used in most nuclear reactors. Most nuclear reactors may also have fuels like plutonium 239 or uranium 238 or thorium 232. These nuclear fuels are inserted in the initial stage of a nuclear reactor and can last in a nuclear reactor for a period of few months up to 5 years, and are part of the initial cost as was discussed in the previous video lecture. Also, the uranium is present in the nuclear fuel as a dioxide. Most common uranium dioxide is found in most nuclear reactors and is used as a nuclear fuel. Nuclear power plant is a place where nuclear fuel is converted into heat energy using a nuclear reactor, and principles of thermal power plant are used to convert this heat energy into electrical energy. The plant layout is shown in the figure schematic here. It mainly consists of the nuclear reactor, control rods, heat exchanger, steam turbine, generator or alternator, and the condenser. The nuclear reactor is a cylindrical vessel which mainly consists of the uranium 235 fuel in the form of fuel rods surrounded by moderator rods and control rods. The fuel rods are the main initiators of nuclear fission reaction, wherein slow moving neutrons are bombarded. When these neutrons are bombarded, fission reaction chain reaction takes place. This chain reaction can be controlled by controlling the speed of the neutrons, which is done by the moderator rods. These moderator rods are made of graphite. The control rods made of cadmium are inserted or are withdrawn regularly so that the power demand can be met satisfactorily. When they are withdrawn, the neutrons which undergo the chain reaction are more in number. When they are inserted, these cadmium rods, which are also called control rods, absorb the fission neutrons, and hence the chain reaction is arrested. So the insertion and the removal of control rods is automatically done to meet the power demand. The heat generated from the nuclear reactor is absorbed by sodium metal, which is the primary solvent. The primary solvent is taken into a heat exchanger where we have water as the secondary solvent. The two solvents are not mixed so that water does not come in contact with the radioactive waste present in the sodium metal. The heat absorbed by the water, which is in the secondary loop, converts itself into steam. The steam is then passed into a steam turbine, which is expanding the steam, and mechanical work is done by the shaft connected to the steam turbine. This shaft is also connected to an alternator which converts the mechanical work into electrical power. The electrical power is then connected to the grid via a transformer. The steam which is expanded from the steam turbine is passed through a condenser where it is condensed into water again and can be reused. The condenser has cooling water which is circulated as the tertiary loop or the third loop of the nuclear power plant. Hence, nuclear power is generated based on the same principles of thermal power generation. Only thing we have to keep in mind here is that the heat is generated by the nuclear reactor. Summarizing this video lecture, We note that the site selection criteria mainly depends on two things: availability of cooling water and the remote location of the nuclear power plant. Also, we note that nuclear reaction can be of scattering type, it could be absorption, it could be fission reaction. These reactions have to be controlled, and nuclear fission reaction is controlled for peaceful purposes like power generation. Also, the nuclear power plant is nothing but a thermal power plant where heat is generated by the nuclear reactor. Thank you guys for watching this video.